What's up? What's up, everybody? Welcome back. Today we are working on our neural network training framework, and today's goal is to do some form of barcode isolation. So we've been working on the idea of integrating a barcode scanner into our food tracker app, with the idea of I can like take my phone, kind of like scan things as I put them in my fridge. Then we know how much stuff we have, and we can like use that to say, oh, you used this much milk, you started with this much milk, that means you have this much milk left, and you have enough to make like some things but not other things. Hand wavy, right? And so we started doing like we made like a hand rolled barcode scanner a little bit. We got like kind of far on this thing. We could like isolate a barcode. We draw a little red box here showing where it is, and then we like tried to do some image processing on it to do some scanning. But we found that there's like lots of situations where like the hand rolled version needs to get kind of complex, right? So just looking at these are all photos that I've taken, right? These aren't like from the internet. Stuff like, in some cases you have like fairly blurry images, right? And that means that the difference between dark and light is kind of low. If you huck a shadow on top of this thing, it becomes like some dark sections are actually going to be lighter than some light sections. So you have to do like some sort of like, detect like local contrast enhancement or something, some sort of like, and even then you have to find out like some rules that will make it so that like you detect these edges, and in here like can easily tell like this. Trying to draw like hard lines here of like 1, 2, 3, 4 is like kind of difficult. There's also stuff like this where there's like occlusion of the codes. And so like if you were to just do like a single scan line across here, you would fail. You need to do something like leverage the 2D information and like figure out what you think is like in a bar and out of a bar. You have situations like this where you like have like mirrors like you have like the bars are made of etching out the coating here and like showing the aluminum on an aluminum can raw, which means that these things are just mirrors. You've got like lighting issues. All of this stuff makes it like kind of hard, right? So our thought is we'll build a neural network to do this for us. We're trying to compete with our hand rolled version in terms of speed, right? So hopefully something that does very few image transformations, it gets the right answer with very little computations that we can run it on our phone real time, 60 FPS. And so we've been like building up our own neural network training framework from scratch. And here is his current state. We have him attempting to predict orientation of some squiggly lines, right? So this just started training. We ran a little bit. He's running a few convolutions. And we can see like the blue line and the red line are kind of close together, which means he's like kind of learning something. Today's goal is to try to like go from this into something a little bit more useful, right? So, in our original barcode scanner, we ran a couple gradient detections, 2 kernels. One to go left and right and say, what is like the horizontal gradient here? What is the vertical gradient? And from there, we could kind of look for sections of the image where a lot of those gradients like lined up with each other, right? So a barcode, we have this thing, all of our gradients are going to be like horizontal here mostly, right? So we like kind of like clustered those things and drew a box around them. It would be cool if we get to the point where we had a neural network that did that today. Or at the very least could mask out a bar. I've been looking at neural networks. This YOLO V1 I feel like is like a pretty good simple and like has a few ideas in it that I think will be good enough for us, right? So the main idea that they have here is they start with like an input image and they run a few like transformations over this image where they say, neural network, could you please learn some features about this thing and like use those features to learn other things, right? And the big thing here is they start with like a pretty big image, 448 by 448. And what they do is they take like the original RGB channels and turn them into like 64 things that are learned by the network, right? And then they immediately make this thing smaller, right? So they take the 448, they look at like groups of 4 pixels and they say, give me the biggest thing in these groups of 4 pixels for each like transformation that we did. And then they do that again, but they get thicker and thicker and thicker. So the smaller the image gets, the like more things they can learn about it without like overloading compute. And eventually they get like really small. They get all the way down to like a 7 by 7 image at the end. And what they do is they like take that 7x7 image with like a bunch of like things that they've learned about the picture through this process, like 7x7 by 1,000 things, right? And they take that and they like immediately go from there to they say, let's just look at all that stuff and see if we can use that to predict for each pixel in this 7x7 image. Is there a thing there? What is that thing? And like, what is the bounding box of that thing? And they predict like many bounding boxes at the same time, but really like the idea here is pretty straightforward, right? They say, run convolutions, which is what we did in the manual version, right? We ran a couple convolutions, but they run some more to get smaller. We can probably get away with very few. Then they say, using that data, predict your bounding box. And we did something similar, right? We tried to do like manual clustering from like our thing, but you can imagine that like we could get something similar through a network somehow, right? So I think what I want to do is I want to try to like mirror this in some way with just way less information though. So the first thing we have to do though is we have to like come up with some training data. So like no matter what the network set like architecture is, we need to figure out what we're trying to predict. So the first thing we're going to try to do is make some data that looks like barcodes that we could try to isolate. We need to pick like a resolution. We need to pick like, you know, barcode size and stuff, whatever. Then we need to implement this like max pool thing. So this is like kind of their biggest trick for how they make the images smaller is they say, look around you, pick like for each section of 4 pixels, pick the biggest one. We need like a kernel that will do that, or like a neural network layer that does that, as well as like preserves gradients for backpropagation so that we can learn. Then we need to like do our like calculation of like correctness with the new data, do some training, and then if we get to that, I think we're going to start with masking at low resolution, and if we can get the masking working, then the bounding boxes should be pretty easy to tack on after, I think. So that's kind of like the general plan. We'll kind of see where we end up. But yeah, that's what I want to try. Okay, so the first thing we want to do here is figure out, we have like image generation where we kind of like have a bunch of randomized parameters that generate barcodes, right? So what we need to do is we need to figure out what parameters kind of make for something interesting here. So can we start by just kind of fiddling with this stuff? So our initial thing, we wanted to predict like bars that were big, so we can kind of just say, fuck that shit, and let's get like way fucking smaller. So like maybe like 0.4 to like 0.6. I think this is in width field of view, so probably something like in the range of 0.2 to 0.6 might be reasonable. The pixel offsets here are quite large. Also, we can tell immediately that the resolution here looks too low. So let's kind of bump that up a little bit. So I think we were doing 64 here. Can we go like image size here is, let's do like 256 maybe initially. Image size. All right. That's better. Size here is like, that's way too big. Okay, so let's adjust. So X scale range. Oh, aspect ratio range here. I guess we want like, probably we want mostly kind of short, right? So maybe 1.0 at the maximum and like maybe 0.4 at the minimum, maybe. Okay. I think the upper size here of like this 0.6 is too big. I'd like to keep it kind of smaller. So maybe something more like 0.2 to 0.4 size. And then I think that the wiggle parameters here are a little too extreme in some cases, but maybe that's okay. And then I think the blur is also a little too aggressive, but maybe it's fine. Like here, that's a really aggressive blur, but I guess like the blur isn't always that aggressive. Sometimes it's also very chill. And so I guess if we have kind of samples of both chill and aggressive, we're probably fine. Is that your own debug GUI as well? Yeah, completely from scratch. Right, so this is like pretty not blurry. So I think we're probably fine. Yeah, for like isolation, maybe that's not a big deal. And then I think that with the backgrounds just being like constant color, the problem is like too easy, right? I don't really like that. So maybe now is the time to bring back the dolphin. Yeah, what happened to the dolphin image? Yeah, exactly. So I kind of removed it as I was playing with trying to get like the image generation commit in initially. So I think let's bring that shit back. Let's bring that shit back. So we need to what my initial thought is just take a picture and slap the barcode on top of that picture. Let's maybe have samples of like many pictures, probably. So can we do something like we were going to use Google Open Image Dataset. This is what we were going to use because what this guy has in him is every single, like, there's lots of pictures in this dataset that have like masks, and those masks of like, you know, if you like mask up this camera, those can be kind of like nice in terms of we could use those as like a label, right? So like if I have, do I have anything here? I have like a ketchup bottle, right? So like the ketchup bottle has like a huge chunk of like white stuff here. And so like we can use the masks to kind of like say, hey, if you have like a mask of a thing on top of like stuff, then like you'll have somewhere that we can use as like a label for later. Was kind of like the idea. I think we figured out how to download this stuff at some point. I think it was like download here. I think it was like we used AWS to download like some subset of images. I would like to download like at least like 10 or something and just see. Yeah, download here. Hype. And then I think in here there's a command you can run to just download some stuff from the validation set. We don't need the full shebang. And we can just get away with like a few images. Like we don't really need a ton right now. I just want like more than 0. So maybe, and more than 1 probably. So can we do like backgrounds or something? And can we just kind of like slap this here for a second? And he doesn't like that. Why? Also, AWS S3 help. How do I fucking see this thing? What are our options here? We have copy, move, sync. If we use sync, what are we supposed to be doing here? Sync from there to like here. So we should start seeing just like some images show up. All right, and if I just like hit Control C here, that's like enough for now, right? Can I open a fucking picture, please? Boom, 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 boom. Okay, so this, dude, what was that? Why do we just have like a photo of like someone crawling on the ground? That's crazy. Yeah, okay. So we have to choose if we want to crop or resize this stuff. I don't feel comfortable with like the photos of like children, you know? Hello, what do you think about Zig? I've been reading a lot about it, was thinking about learning it. I think that if you like C, but you want like a little bit of like a modern twist, it's pretty good. If you like don't like C, I would be surprised if you liked Zig, but I like it. Okay, so what do we want to do here? I guess I want them all to be constant size. And we could do the resize like in our image loader in like Zigland, and we could like write our own like sampling thing, which is like very doable, but I just don't want to do that right this second. I kind of want to just like rip it. So can we for now just like resize all of these images to be the right size? Images might be tagged, so you can probably filter about that if you have the metadata. Oh, like for like no children? Yeah. So what did I say? Like, let's just start by using like image magic to like make everything What was our like image size? Was it 256? Yeah, image size 256. Okay, so let's just like make a bunch of like convert these all into 256 by 256. Image magic. I think it's spelled with a CK at the end. And then it's like image magic convert change size or something. Let's just see. Magic size. Okay. So can we do like make dir backgrounds 2, and then we can go to backgrounds 2 and say for I in backgrounds, for image and backgrounds, do echo image done. Background star, do convert size 256 by 256, I'll image, and then like base name image, I think. Something like this. Yeah, that looks like the right fucking command, and we just like remove the echo. Okay, he's mad because I typed magic. And then if we exeg open this guy, what did it do? This did not do what I wanted. Why the fuck not? Like, what the fuck? That's very much not 256 by 256. Is it like resize? Why is this not doing anything? Size. Am I like stupid? Is it resize or something? Resize the image. Set the image geometry. See this about the geometry argument. We can just do it with by height. Let's try that. No images found. Oh, is it like this? We do image then resize. Okay. Exeg open this guy. He is preserving aspect ratio, which I don't want. I throw an exclamation point at the end for aspect ratio ignored. Like, seriously, go fuck yourself. I will, oopsies. And do I have to escape exclamation points in Bash? I don't think so. Okay. Oopsies. There we go. That's photos of stuff at 256 by 256. Chill. Chillin'. All right. We need STB image. We've done this before, but then I deleted it because it like I didn't use it in that version. So we've got to quickly just yoinkies this guy again. It'd be a shame if there was a barcode in there. Yeah, I mean, hopefully if there was, it would be infrequent enough that it doesn't matter. But also, yeah, that would be kind of funny. Save as work. Where are we? Smelly source probably. STB image H. What's the thing we usually have to do in Zigland to make this work right? We do STB image C. We define STB image implementation, and then we include STB image.h. We go to our build zig, and we add that as the thing to our image generator. So we say exe. Why don't I have... What is happening? No autocomplete in that window. There we go, this is better. Root module, add C source file. File is source stb image.c, and then we also have to say here add include path of source so that we can include the header. All right, we chillin'? All right, looks like it. Image gen. So let's do something like somewhere we have to like load in this shit. Oops, this would include was left in there from before. Oops, that shouldn't have gone in. Whatever. I guess it was in barcode gen. Probably. And in here, we probably initialize this guy with the background imager. Right? Something like this. And then what we do is on initialization, we probably like load that stuff into a tensor, right? So we go background imager iterate. Maybe here we'll do this is a like this so that we can open the dir. Open current working directory, open dir with the background image dir. Like this. Vimlog 1.2 gigs. Yeah, I should remove that. I keep forgetting. And then does this guy have options? Yeah, we need to say like, I need to be able to iterate this directory. If I remember correctly. If I remember correctly, and then we have dir iterate while it next. It looks like this thing needs to be tried. Still no? Oh no. What the fuck? Then why is he mad? Entry, I guess. We are going to open this file. So I guess first we want like maybe it makes sense to read the paths first. And then yeah. Let's do this. We'll say paths. Well, do we have like count? Like does this thing have like a way to count how many things are in there? Feels like you might. Walker, walk, close, open, count. Num children. Maybe not. Count files like how like Linux how many files enter or something. See. Do I just have to actually count? Yeah, you do. You just actually have to count it. I see. Okay. Okay then. We'll fucking count it. I guess what we'll do here is we'll use like a entries or like images, image paths. Yeah, let's do this. Okay, let's start pulling in like the bullshit. Scratch is going to be a stud. Linear allocator, probably. And we're gonna be like checkpoint is scratch checkpoint and defer scratch restore checkpoint. And then here we go, we're gonna make a image paths is gonna be a list of shit of paths like this. Okay. And we're going to initialize this with, scratch allocator a couple times. We're going to say, like, this thing will probably be, like, under 100, but could be, like, 10,000 elements large. Probably. And while we iterate these things, we're going to be, like, image paths, append some shit, entry dot name. And then what is, like, the rules here on this iterator? Like, is he giving me paths owned by the iterator that I have to copy? Almost surely, right? Yeah, so this is the buffer here, probably. And when I call next, he's probably saying, like, what the fuck? Why are none of these Linux? Oh, I see. Here we go. So he's got a buffer here. Probably when we call next, he's like, give me the name and put them in the buffer. Almost sure, certainly, right? Name, slice to, what the fuck? Linux entry name. And he's using the buffer, yeah. Okay, so this is backed by the iterator itself, which means that if I want to store these for later, I have to copy them, which makes sense. So here we're gonna be like scratch allocator dupe. U8 with this thing, easy peasy, lemon squeezy. Okay, so we have all our image paths now, and so now we can say, we can like allocate a tensor on the GPU that's like of the right size, right? So we should be able to like create tensor, maybe filled with zeros just in case something goes wrong. Or maybe with nans is better, just to like really fuck shit up if we fuck shit up, you know? So dims is going to be 256 by 256 by whatever, like number of images. Fix me like image size. What if images in dir aren't 256 by 256 lol? Okay, and then we fill these things with stud math nan number f32. Just to really fuck shit up. Backgrounds is like this. Okay, we're probably gonna have to store that somewhere. Backgrounds is going to be a CL math executor tensor, probably. Yeah, something like that. Okay, so now what do we do? What do we do here? We like, for each image, is gonna be like image paths iter, while path iterator next. We have path. We go like, I guess this is like dir open. Is it just like straight from SCP image? I guess so, right? So we like load this thing from the path. So when we iterate this thing, is it giving us directory names like relative to the directory? Probably, right? Almost certainly. So this is gonna be like we're gonna do like quick little checkpoint. We're gonna do some allocations in here. And then we can do like name, like full, like current working directory, rel path. I guess we should just do this up here, to be honest, right? We should just, as we do these, do like scratch stud format alloc print with scratch allocator. And then here we can just go like straight to this slash this. And here we're like background image dir followed by entry name, chill. Easy. So now we don't have to do any like allocations over here. We just load that motherfucker. So here we're like, load that motherfucker. And this guy wants a bunch of other stuff, like var width is an integer, height, desired channels is 1. So I think we just go like width, height, null, and I want grayscale images. Yeah, and this is gonna give me like a data pointer. Assert that this isn't null, I guess, for now. I guess we should be better. If this return error open image or something, sure, whatever. If width is not equal to 256 or height is not equal to 256, return error, image dims or something like that, whatever, who cares. And so now we have like a 256 by 256 image. Surely we should be doing like a defer stbi image free of the data pointer, easy peasy. And then what do? We like upload this to this tensor somehow. So like, uh, what are we looking for? OpenCL write image, write like write data or something. Image write functions. The fuck? This is not what I want. But this is interesting. I didn't know they had stuff built in here. But I'm looking more for like a read, like how are we, write buffer, here we go. And I guess our write buffer needs an offset value here now. What is the unit of the offset here? In Q, write buffer. So let's read this. CL in Q, write buffer. Offset is the offset in bytes in the buffer object to read from or write to. Yeah, okay. So here we're like, I want to write to some offset in this thing, which goes in 0, 1, 2, 3. So this goes here, and then it's a U size, right? Size 2, yeah, okay. Okay. Cool. And then with our math executor, does our like read API work? We have like 2 CPU here, which doesn't really do what I want. Okay. Okay, what I'm gonna do for now is I'm actually going to just like raw dog this for a second. I don't really care. Notice Duck AI has GPT-5 Mini now, asks it to code some stuff, and it actually asks for specifics before spewing hallucinations. Seems like an improvement. Hell yeah, dude. I did notice, yeah, I have noticed that, however much I clown on ChatGPT for being like a stupid piece of shit, ChatGPT 5 does seem to like be less stupid. It's impressed me more than the other ones have so far. But that's a low bar. By some metric of low, I mean, like, I admit from the start that like the technology is very impressive. Very impressive. But it's like not really useful to me very often, but I think it's getting better. Okay. So now we should be able to be like we need to, this is going to be RGB, right? So this is going to give me like numbers between, or sorry, this is going to give me U8 numbers. So we actually need to like duplicate this. CPU floating point is going to be, I guess here, we can actually just allocate this once and use it everywhere. You know, like this. And then we're gonna go like for data pointer 0 to 256 times 256. Value, we are going to say that we are taking that thing and putting it in CPU F32 at the same index. But we are going to be like float from int v divided by 255. 256? 255, right? 255, I think. As a data point, I've never used it before, but Gemini was able to add counting initialization to Sonali first try. That's not too bad. Not too bad. Okay, then we just like do write buffer. I think we need this to be, we need to do this synchronously. Which means that probably we probably want to do this. I think. Right, we're not creating any more tensors in here. So the event will go onto this allocator and then we like clear that shit out later. Sure. Our buffer is backgrounds buff. Okay. And our offset is going to be, I guess, image offset is equal to 0 here. And we use that here. Okay. And the content is CPU F52. Okay. So what we need to do here is just on every one of these, add 226 times 226 times size of F32. Easy. And then I think this guy needs to be a byte buffer. Yeah, so this guy needs to be stood mem slice as bytes like this. And then I think we're kind of chilling. We get like here a result. And then we do res wait and we move on to the next. So I think that this should be pretty good. I think that we should now at this point have a bunch of backgrounds packed into GPU memory. Arguably, you should not hold them all in RAM all the time, but this is fine for now, right? So what we need to do now is when we have our randomization, when we like make our bars, probably this is part of the first pass. No, when we run our module generate kernel or something. No, that's not it. Oh, instance ran params. This sounds right. So in here, we want to pick a number that's like num images, right? So we're gonna take in like self dot backgrounds dims 2 or something for width height then number. This is going to be num images here. And now our kernel that like instantiates random parameters for this thing needs to take that in. So wherever that is, I think it's here. We put it as num images here. We just want like rand u long between image index is between 0 and num images. Easy. We put that as part of our concrete parameters here. So we just say uint image index like this. Image index is image index like this. Then when we are generating the barcode, we have like you know, like it sample image buff, I guess. And we look at, hold on, we're figuring it out. Somewhere we like set the background color here. And so instead of doing that, we're gonna go look at we're gonna look at like image buff plus something. I guess like background buff is a better name for this. So we're gonna look at the background buff plus width times height times our params image index plus pixel ID. And this is like what we're going to assign to this thing. This absolute shit show. Image size is oh, this is wrong. Our params dot this width and height are from something else. Oh no, width and height. Not sure. Let's take a look. When we call this thing, what's going on? When we call this thing, we call with something. Make bars, we run first pass. He's passing in the size of the image. Yeah, so that's right. Cool. All right. That's like a maybe. And then we have to pass in the background buffer here. So we have, hello? What do we call this shit? Backgrounds. Okay, cool. That's like a maybe. I'm like not 100% sure that this won't work right now. Not 100% sure that it won't work right now. What's he pissed about? Is that not what this thing is now? Background imager, background 2. Wait, what's the problem? Did I not save? Hello? Expected 4 arguments? What is the 4th one? Oh, or the scratch allocator. Of course, my bad. Variable here. This thing's mad because I didn't write try here. This is mad because I didn't write try here. This thing is mad because this was based off U sizes, which it doesn't like. Fuck. As U32. Okay, this thing's mad because I didn't write try here. True. C import failed. Interesting. Why? STB. Oh, because probably in our build, we only added, this STB image stuff was only added to smelly, not image gen. All right, let's try that. This guy's mad because expected a C pointer to constituate, found a slice to constitute. Yeah, that's fair, huh? So path here needs to be null terminated. Ooh. Print Z here. This guy's got a type of null terminated, and then when we pass into STB image, we can do this now. And then I think that comes for free. Yeah, nice. It's barcodes too, right? Or backgrounds too? And then this guy needs like a scratch allocator. Which we don't have right now, so if true, unreachable. We'll fix this later. I just want to get it in image gen first. Okay, open image failed at 80. So can we see what we're trying to open? Because we clearly didn't understand. We clearly didn't understand. LS backgrounds 2 003. Okay. Is it broken? Seems fine to me. Then what the fuck is the problem? Oh. I'm failing on success. Okay. Okay. That's actually something. Look at that shit. Look at that. That's kind of hype. That's actually like fucking hard. Like, to be honest, I'm looking at that and I'm not like 100%. It's like not like incredibly trivial, which is good. Right, that's good. We're hoping that he starts to learn something a little bit more complex. I mean, I can find them, right? Which means that it's possible. Yeah, hype. Hype! Cool. Yeah, like that. That's actually like really fucking hard. Um, that's really hard actually. So that's interesting. Okay, cool. Um, okay, what's the play now? Uh, we fix that unreachable. Okay. Uh, am I okay with like this data? I guess we want to look at next. We need to check that the masks are right, probably. I don't know if we've checked that. So can we, in the visualizer, can we show, can we just make like a second image view here? Image view to, is this really how we make these things? There's no like init function here? Wow, we're fucking crazy. We're crazy. Image view Alec. We're idiots. This should not be like this. But whatever. Okay. Image view. Where does image view go? This updater surely wants, like, we'll call this mask view. Why does this guy even own an allocator? What is this thing fucking doing? Oh, I see. Never mind. That makes sense. That makes sense. Mask view. Mask view. This guy needs a mask view that he does something with. Don't know what yet. Presumably whenever he updates his image view, we probably have like mask image CPU is masks. Okay. Mask view set image mask image. Okay. And does this not need to be like sampled somehow? I mean, I guess not. I'm a little confused about why this is okay. Oh, I see. I see. He's like yoinking it out. Sure. Okay. And then we just need to do something like put this in the layout somewhere, right? So can we just like, where does image view go? Here. Can we just be like layout push widget mask view as widget, and then these guys need to be like boxed probably. Because they try to fill up the available space. So it's like here somewhere. Make box. Use this guy. And can we like clamp him to like 500 by 500 or something? For now. And then can we do the same thing here? Yeah, something like this. Something like this. Oh, okay, it's just down here. This thing is like way too tall. Make it fucking smaller, please. What is going on here? What the fuck? Is this image view stack like filling this fucking screen or something? What the fuck? This, I feel like, is not behaving the way I expect it to. I mean, this feels okay. Alright, it's kind of hard to tell with this garbage view that it's right, but at least there are masks that line up somewhat. So I'm just gonna go with yes, I think that's right without thinking about it too much. Because I don't want to fix this. Fix me, like, what the fuck layout. We'll come back. We'll come back. Okay, so I think we have barcodes generated. So I think the next thing to do here is to try to make some form of, I think, actually, no, I was right before. Doing max pool first makes sense. So we need, as we make up, like, build this, like, convolutional neural network, we want to build something that will take, like, our big images, our, like, what are they, 256 by 256? We want to, like, get them down. Zoom in, please. God, fuck, I can zoom. Okay, there we go. I'm not mad. I'm not mad. I'm fine. I'm fine. We're chilling. So we need to, like, oh my god, it only works sometimes. Fuck. That will, like, pool sections of the image and, like, make it smaller. Right? So what they do is they do, they, like, do some transformation on the image. You get, like, your, like, edge detection image here or something. And then they say, like, for these 4 pixels, like, take those 4 and just pick the fucking biggest one. Right? And then, like, for these 4, just pick the fucking biggest one. And these 4, pick the fucking biggest one. So we should just do the same thing. We could even get crazier if we wanted to, like, get, like, smaller faster. We could do, like, 3 or 4 by 4 if we really want to get crazy, but I don't really know what effects that has. So let's just start with a 2 by 2 and kind of see where that goes. Oh, while we're here, though, we do have, like, this is going to be broken right now, so can we, at the very least, do, stud alloc, buff allocator init, let's just get, like, a meg of stuff for now for caching the, no, wait, we don't have to do this way, actually. We can use our existing CLalloc. This is fucked, but whatever. Whatever. It's good enough for now. Good enough for now. So we need somewhere to write a kernel that will do max pooling. So can we just say, like, source math executor max pool CL or something? We make a C function that is run for every output pixel, right? So we'll call this max kernel max pool, and he's gonna take, you know, our inputs, our outputs, and how many things we're outputting. And he's gonna be like, let me get my global ID. He's gonna be like, if you've queued up more work than we actually need, then, like, I'm gonna turn myself off, not do any work here. Now we should be, like, on our output pixels. So we probably need, like, at the very least width, right? Do we need height as well? Do you research the math stuff off stream, by the way? It seems like it's not that bad if you get past the jargon reading papers. Some of it. It depends on how confused I am. I usually take, like, a quick look, and then if I feel like I get it, I don't think about it more, and if I'm not sure that I get it, I'll read a little bit. What's CL in this instance? So OpenCL is like it's like OpenGL, but for compute. You can think of it that way, right? So there's many GPU manufacturers. They all have, like, different drivers for how you talk to them. But OpenCL is like, hey, I want to run a function in C many times at once. This is how we do it. And then, like, the GPU driver implements an OpenCL API. So you can kind of think of it like generic CUDA. I don't know how to do some files. That's fair. That's fair. This is just like C. This is just a C file. Okay, so this is like a function that will be compiled for my GPU at runtime, if that makes sense. So what's going on here? I guess like we have like our output X and output Y are is going to be like useful in some way, right? And then surely we have like stride in here as well, probably. So this is like global ID percent width, and our output Y is this over width. So I guess this is all we need. But we're probably going to be max pooling. This is probably going to be like width, height, channels, number of images, right? We don't really know. We don't know how many. How do I say this? We're gonna have like this is gonna be happening for many images for many channels at once. That's all. So in reality, though, you can kind of treat the C and the N as like not useful, right? So if these things are like sequential in memory, as like you have like red channel, if it's like if memory goes like left to right, top to bottom, you have like red channel, green channel, blue channel for image 1, then like red channel, green channel, blue channel for image 2. If you just like pretend these are just new images, that all works. So you don't really need to think about channels and number of images here. You just like queue up more, I guess. So yeah, I think we're chilling here. I think we only need width. Okay. So what we do now is I guess we say like in X is output X times stride, right? And in Y is output Y times stride. And we're gonna go like for int X is 0, X is less than width. We do something, and we do this for Y as well. And we actually don't start it. We start it in X, or in Y, sorry. And this is X is less than stride actually, like this. Nice. We say like max is 0 probably, or like negative infinity. Right, something like this. Then we just take the max of the 4, right? So it's like out, I guess. Out is equal to the maximum of the thing at this place or existing out. So where does this come from? This is like our input at X times width, Y times width plus X. Easy. Easy. Okay. We need to clamp Y somehow. And X, right? If we go out of range, if X is greater than or equal to width, we continue. I don't know how like fuck this is for like warp optimization or whatever, but it's probably fine. Sure, and then we just like, oh, out is already used here. Fuck, out val. There we go, and then out global ID is equal to out val. Okay, seems reasonable so far. In terms of gradients, I guess we just like rip this shit again, huh? So like we could write down what we picked and use that for backpropagation, right? Because when we go backwards, we have to say like which of the 4 inputs that we used is like the one that contributed to the output. Or we could just like calculate it again. And I think calculating again is easier than tracking, I think, and probably not that costly in this scenario. So maybe here we do something else, right? We do max index. Yeah, so this is gonna return us like a uint. So I guess we want like an iterator that will iterate over the relevant pixels for our thing, right? Because when we, maybe not. Let me think for a second. So I guess on back propagation, how do I need to draw something. So on forward, we're taking like these 4 pixels and we're like feeding them into one output pixel, right? And then on that output pixel, we have like loss contribution here for the way back for like how much did each of these pixels contribute to this? Like how much did this pixel contribute to the answer, right? When we're going backwards, we have this, and we say which of these 4 pixels contributed to that, right? So if we initialize this as zeros, then all we have to do is pick the right one to like copy paste this value into like whichever one contributed. Yes, that's what we have to do. So max pool grad. So he's gonna be like downstream grads. We have our input, output, and then we're gonna have like the same parameters here, right? And I guess that means that like almost all of this stuff we want to be like extracted. So I think what we do is we say, if we do like max index here, based off our inputs, we can just kind of say like, maybe here we say like, I don't know, man. We'll see. Is everything here used? In probably out is not used. Yeah, out's not used here. But width is, height is, stride is, and is probably not anymore. And here I guess it's like we just track like uint max index as well, right? And then we're here, we're like max index is y times width plus x. And then we return max index here. Maybe we call this like calc max. And then here we return the out value for if somebody wants to use it. Okay, cool. Then here we delete everything and we call calc max with like global ID, width, in, width, height, stride, and this must be like out val, I guess, like this. And here we probably need to initialize this thing to 0 or negative infinity, my bad. And now for the other guy, we can do this again. But this time we get like max index here, and we just say like output at max index is equal to downstream grads at global ID. I think. right? So like we initialize this shit to 0, we only run this for each of the gradients, and we just copy it to whichever one is relevant. That feels right to me. Feels right. Not really entirely sure, but it'll be easy to test this. Okay. Math executor. Let's get these kernels. So let's do max pool grad. And we have max pool. Easy. And then, so we need this program. So we have max pool, max pool CL, I guess. And then here we pull these things out. So we say max pool kernel. I guess we need like max pool program. So we like compile this thing for us right now. Boom, we get the kernel out. So we have the max pool program dot create kernel. Max pool, easy. We got grad kernel, max pool grad. Is that what we called it? Yeah. Ooh, we did underscores on max pool. That's crazy. I actually feel like there shouldn't be. I've changed my mind. I don't know why, but it just kind of feels correct that way. You know? You know? Then we just go like max pool kernel is max pool kernel. Grad, throw a grad on here. All right, and then we have to like make functions for this thing, I guess. So I guess maybe by convolutions kind of makes sense. So let's fucking figure this shit out. Max pool. Okay, so what are we expecting from our inputs? We probably want like in dims len is not equal to 4. We're probably confused. We probably want like, so this is going to be width height channels n. And here we're like, we want to stride here, almost certainly. Right, so this is going like in is this, and then out is width over stride, h over stride, c n, right? Yeah. Cool. Cool, 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 cool. All right. So I guess we have like out dims is you know, make some U32s, I guess. 4 of them, I guess, and it's like out dim 0 is in dims get 0 over stride. 0, 1, 2 is in dims get 2, and 3 is 3. Easy peasy. This is we're gonna call this buff here, and then we're gonna say out dims is tensor dims as a type, init reference to out dims buff. Easy. And then we like make the thing, right? So we say self create tensor on initialized with, you know, this bad boy. Easy. And then we execute kernel, right? And what does this guy want? He wants the kernel. So this is the max pool kernel, I guess. Everyone else says kernel here. So we should do that as well. Or else we name Clyde. Kernel. All right. And then how many elements here? I guess ret elements, right? Okay. And now we need to like figure out what the inputs this guy are. So what we got? We got buff is whatever the fuck. This is in buff, like this. Out is ret buff, okay. And then width and height here. Is this the width and height of the input or the output? I think it's input. So we should be careful with that. So these output values are actually fucking wrong then, right? This is like this. Gotta be careful. Okay. So we can actually do this the other way. So our out x is in x over stride, and our output y is in y over stride. There we go. That looks a little better. All right. Cool. That seems right. Okay. So here we're looking for uint is input width. So in dims get 0. And we're looking for 1 here. Then the stride is our stride that we asked for. And n is n. All right. So we should be able to bang out a quick test for this. Our test at the bottom, what are we doing? Yeah, we do test at the bottom. So what is this test called? Max pool. And so we create a fixture to do some shit. We probably have some input. So can we just do I don't know. Let's try to do like, so this is, we want this guy's gonna be the bottom right, this is gonna be top left. Here, let's try to get a top right. And then here, let's try to get a bottom left. So that's fine. I guess we should use different numbers in each of these two to make sure that we're not like accidentally looping around somewhere else. So can we do like 1, 2, 3, 4, 5, 5, 6, 7, 8. So bottom right, top left, top right. So we have 9, 10, 11, 12. All right. And so this when we wanted bottom right? So 12, 13, 14, 16, and 15. Okay. Cool. We like shove this shit on GPU. We say this is a what, like 4 by 4 width, maybe 2 height, 2 channel, 1 output. Maybe. Sure. We should probably test 2 outputs, huh? Probably, right? Can we just do something like a... How do you do increase again? Not that. There we go. Just increase everything by 1. Oh, what the fuck? Wait. That only increased the first digit. Can we do 4 control A? No. I guess we do this instead. record macro, jump word, increment. Boom, 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 boom. Oh, good enough. Good enough. So now we can do 4 by 2 by 2 by 2. Okay. And we're not transposing, we're max pooling. And here we're expecting what? Try stood testing, expect. We're expecting like dimensions. We want 2 by 1 by 2 by 2. 2 1 2 2. Okay. Okay, and then what? I don't fucking know, man. I don't fucking know. We want like, I guess we have expected here. So we're like 4, 8, 12, 16. And then here it's 5, 9, 13, 17. Yeah. We load this shit to CPU, I guess. Uh-huh. Uh-huh. And then we go like 4 expected. Out CPU, we have like expected actual, and we're like try stood testing, expect equal, expect approximate equally. X actual 0.001 or something. Zig build, and we want to run test now. Fuck! Nothing ever works. Max pool CL not found. The fuck? Ah. Oops. Wrong folder. And then we forgot the stride. We forgot the stride. This guy needs our... Oh, that's interesting. Can we just not load STB image for the tests? That would be great. Yeah, can we just not fucking do that? Maybe it's fine if we just like add the import or something. Why is this even being used here? Like, there are no tests in here. I would have thought this is fine. But whatever. For now, let's just do add include path. For now, I don't think that should be needed, but whatever. Okay, and then this guy's mad because I didn't allocate properly. I actually don't know where he's pissed about. That would do it. Oh, he's mad here too. Alright. Let's take a peek. Fuck! Expected needs to explicitly say I'm a bunch of floating point numbers. Okay, now this guy's mad because, like, I don't really understand why barcode gen is getting in here, to be honest. I'm gonna put a fix me on this. I don't think barcode gen should be importing STB image in the tests. I don't think we ever instantiate it. But there's something going on there that I don't understand. Something I don't understand. Well, that's okay. That's okay! Alright. We wait for him to run our tests. Oh! 4 is not close to 8. Interesting. So... actual 4 not within expected tolerance of 8. So that means that he's not looking at these 4 values correctly. He can't be. Are we fucking stupid? Oh. Okay, and then... this is wrong again. I'm an idiot. So we are going... output is... hold on. INX is global ID mod in width. We're running 1 per output. So we have to calculate out at first. It has to be. So it has to be like this, I guess. It has to be. And then INX is going to be output X times stride. And output Y times stride. Interesting. Interesting. All right, maybe this time. We should make this one faster, but whatever. Still no, huh? Negative infinity not within absolute tolerance. Interesting. In X input, we're gonna do like %u, output %u. How have we fucked this up so bad? And then can we filter these tests so that at least it doesn't take forever to run? You know, let them work a little less hard. All right, so we're going 2 to 1, 2 to 1, 2 2 1 1. This does look like it's right. In 2 6, out 1 3. Okay. What am I missing? What am I missing? What am I missing? So we should be running 8 outputs is what we're seeing, right? So 1, 2, 3, 4, 5, 6, 7, 8. That is right. 8 outputs. But this guy is like not fucking making it. He's seeing a negative infinity still, which means that this loop must not be running, right? So Y is in Y. And Well, y is less than in y plus stride? Sure. Y times in width plus x on the input? Seems correct to me. Can we look looking at oh. Yeah, wait, that seems fine. Is it not only less than stride? I don't think so. Pretty sure this is right, but we'll see. Okay. That's interesting. So here he's looking at we only see him looking at the bottom ones, which means that like our global ID thing is like fucking stupid. Our like wait, hold on. Um 0, 1, 2, 3, 0, 1, 2, 3. So our Y, we're only ever looking at the top half, which is confusing. Oh. I see. It's because of this. It's because like our input Y, we're clamping to the height. Yeah. In channel or something. In channel is output Y over in width over in height. And this is percent in width times in height. All right, there we go. Then here we're looking at in channel times in width times in height plus Y times in width. There we go. There we go. We were only looking at the first image. Oh, still no, huh? Why? This is wrong, probably, huh? This is probably like maybe like this. Indexing is hard, man. Indexing is fucking hard. Okay, this looks a little better. So here we're looking at this seems wrong. But I guess this should be like in channel or something here as well. Yeah, so the fact that we're looking at the same element twice is wrong, right? This is a problem. Yeah, channel is always 0. Which seems bad. So we do see... Oh yeah, wait. In... Oh, wait, hold on. In... We want channel here as well. God, indexing is so fucking difficult, man. It's like, it always seems like it should be so easy, and then I just like fuck it up. Yeah, so this is wrong? Okay, input Y. Output Y times stride. Oh, so this is already in Y. I see, my bad. So yeah, this should be like y mod, I guess like in height is what this is supposed to be. Then in channel, output y times stride over in height, I guess. Let's see if that looks right. There we go. 0, 1, 2, 3, 0, 1, 2. Yeah, that looks better. That looks better. Good thing we wrote a test that tested everything. Okay. So now we should be able to throw some gradients in here. So let's just huck some grads here, and we're just gonna go 0, 1, 2, 3, or 0, 1, 2, 3 like this. This is the shape. And then we have 4, 5, 6, 7. And we should be able to be like grads GPU. I guess it should be downstream grads, what we're calling them. And here we take the downstream grads. We look at this as 2 by 2 by 2. Whoa, hold on. Four, 2 by 1 by 2 by 2, my bad. Okay. Then, so this is 2, 4, 8, yep. And I guess we do the backwards version now. Max pool grad, which doesn't exist yet. But we're going to pass in the same parameters, I guess. So here we have downstream grads, input, and stride. Sure. Sure. So our output gradients here is just like create tensor uninitialized of indims, I think. So like the input to the max pool, his gradients are going to match his input shape. That makes sense. Then our n here we said was going to be down. We said we were going to run once per gradient because all of them are going to be 0, right? So we actually didn't want to create this thing uninitialized. We wanted to create this thing filled to zeros, if I remember correctly. So I think that's what we said. Throw some zeros in here. Then we execute our kernel, right? So we have max pool grad kernel, and we need to match the arguments. So we have our downstream grads, we have our out grads, and then we have the same width, height, stride parameters. Okay, sure. Seems simple. And so we just like return out grads. Okay, and so now all we should have to do here is like write down our expected gradients, which are, let's not do 0 in here. Let's do 1, 2, 3, 4, 5, 6, 7, 8. So here we're expecting like this kind of format, except a lot of these guys are going to be zeroed out. So this is the winner here. This is the winner here. This was the winner here. 12 is the biggest. 16 is the biggest here. And then here, it's kind of like the same winners, right? So it's 17 here, 13 here, 5 here and 9 here, and then we just set the numbers to match the gradient. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's 1, 2, 3, 4, 5 already, 6, 7, 8. That seems kind of right. That seems fine. And so can we load our gradients to the CPU? So, grad GPU here. This is grad's GPU, I guess. Okay. Hi. And then here we go for each of the gradients and the expected gradients. We check that they're right. Let's see if that's chill. He's mad. Why is he pissed? Downstream grads. What the fuck is he pissed about? Oh, I see. The fuck is going on? Guards again? Oh my god, what the fuck? Vim is fucked, Vim is fucked. It's fucked. Mayday, 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 mayday. Guards. There we go. Fuck! This is grad CPU. Okay, he's mad. Why? 0 is not in absolute tolerance of expected 2. So this guy is wrong. Did we get this right? Yes, we did. Okay. So the question is how is this getting misdistributed? Bangers are on today. Yeah. One Direction was not cool when it was out, but now 10 years later, it's like, wait, this is a throwback. What the fuck is going on here? So that means, can we print what we got? Like, what the fuck did this thing actually make? Dude, it's just absolutely fucking fucked. That's funny. So, we did something wrong. Max pool grad. So, here, we tried to run once per... Okay, first let's make sure that we're running run times, right? Printf, global ID is this. Let's just start there. So we did run this 7 or 8 times, which is what we wanted. Okay, so for this global ID, we have this max index and downstream value. Let's start there. Okay, so this is obviously wrong, right? 575757. We're writing to the same indexes every fucking time. So what the fuck is going on here? Oh, we didn't fix... If, yeah, what are we doing? If val is greater than out val, out val is equal to val, then this looks like this. Bing, bang, boom. That's better. Nice. Nice! Okay, so now we have gradients for a max pool and a max pool function. We should be able to, like, attach these to some, like, layer that runs, for some convolution. So can we, before we, like, jump into, like, changing the data here, can we do this on the same data that we were previously running? Right, so, like, if I run this right now, does it run? I think it should. I can't fucking type. So this should still run the way it was before, but it's not. That's not good. Why? It's got to be in our like barcode generation, right? Yeah, this isn't valid. This is illegal, what we're doing here. Fine. We were fucking up our allocators. It's fine. I deserve that. Let's just make one of these guys real quick. Just give me like a mega space to play with. Um, we can make this work. Not bad. Not bad. Discord link is in the description if you can see it. Okay, cool. So this is still working. And what I want to know now is if I just like huck in like a max pool layer here, like what happens? You know? You know? Um so we need to make that do something. Max pool. And I guess we were taking in stride here as our parameter, and that's probably it. And this is going to make us like a neural network layer, I guess. So we need a max pool layer somewhere. So we should be able to be like, max pool. So I guess he doesn't actually have any like internal data he needs, but I guess like because like he's not like holding any weights, but he does need like a name that's dependent on the like like the stride, probably, right? So I think we're gonna be like null get weights, and here we're gonna be like null register weights here, and our execution he's gonna be like what is this thing called? Max pool. What is our max pool function called? It's just like max pool. We have our allocator, our input, and then our stride. So we're gonna hold onto that too. And I guess then when we create like max pool layer, this is gonna return it and layer. And he's gonna be like, Alec, create a max pool layer. Here, like, it's a layer interface of this thing. And then it's like, here he's gonna be like, ret is, he's gonna initialize this thing with the stride. Which means that he's gonna make the name here as well. And it's gonna be like max pool stride. Simple. Easy, man. Okay, so that means that like this actually doesn't need to exist. We should probably like ditch this like layer generator thing completely almost. So it's like nn max max pool layer or something with stride 2. We need to be consistent with the name. We think max pool is one word. Okay. I see. This is why that exists actually. It just makes it a little cleaner. We don't have to like pass the same parameters over again. So it's like return nn dot max pool layer executor self cl alloc keep and whatever stride. There we go. Okay. So we should see now that these guys get like smaller. Oh, our tracing executor though. Wait, hold on. This guy doesn't have this yet. Wait, we still need to deal with this. Conv many. Okay. So we need our tracing executor needs a max pool function here. So this guy is in charge of like writing down the execution graph and doing back propagation on that thing, right? So he's got some input and some stride, right? He calls max pool on this stuff. And he then writes down max pool. And in this max pool, he put down the input. So this is going to be the input and stride. He's going to write that down as well because he's got to call the gradient function later with these same parameters. Right? So we need to, in here, write down that we can do a max pool. And this is kind of unique in that it has a stride parameter, so he can't reuse anybody else's stuff. Okay. And then on backprop, we're gonna have to like fucking do something. So we're gonna be like, max pool. I assume that this is gonna look a little bit like sigmoid, in that we're going to get some inputs, right? So this is our input ID. Then we're going to call max pool gradient on this thing with the inputs, but with param stride here as well. We're going to assign our gradients to... We're going to like update the gradients on the input, and then we're going to keep going with params in like this. Easy. Easy. This builds. Okay, so what I want to know now is like, does it work? No, because when we do invalid dimensions here, there's a reshape. Oh, because the reshape is the wrong shape now because that makes sense. Because he needs to divide this by the stride. Right, because this thing has gotten smaller, theoretically. Still no. Because our matrix multiplications now are probably the wrong size here, because our linear layer here is also needs to be smaller. Okay, and so the question is with this max pool now, are we still getting like something that's like kind of right? And we are seeing something learn, and we should be able to see now that like as we move through these like layer outputs. Yeah, here you can see it, right? So when we go from like rel u to max pool, like you can like look at these like border pixels, how they look, and like how big they are. It's actually hard to see, but you can see like they're getting bigger. I don't know if you can like see that very easily. It's like hard to like visualize because it's jumping around, but we are seeing it, which is hype. So it looks to me like one, like if we're learning, that means that the backprop is working correctly, and two, we're seeing like the things get smaller, and we should also see it get faster, which is good. So I would say that's a success. Max pool probably fucking works. Which means that we should be able to just make a new loss function to try to predict the mask. Okay? So what we should be able to do here is just take like the original mask here. Okay, so we are going to change what we are doing in our output layers here. So our network, we want maybe like several convolutions. Oh, we should checkpoint here, right? We should do a checkpoint. Okay. So we want to start by like getting, you know, maybe 8 output layers or something. Immediately max pool these things. Really would be better if we could stride off rip, would be better, but we can't do that right now. Then we're gonna like, you know, do a little more. So this is 256, 128. Let's go again. We'll just fucking like dip this shit down 8 by 8 to 64, right? Get even smaller. We might be able to just go like straight to like 64 over, maybe down to like 32. Do a few like convolutions at that resolution. Maybe go even deeper, right? So now we're like maybe like 32 by 32 by 16 is what we're looking at now. Right, so this what we're doing here is like we start with 256 by 256 grayscale. Then we're turning this into 256 by 256 by 8. You know, we have like 8 outputs here. So this is 8 here. Then we're going down to immediately 128 by 128 by 8 again. 8 depth. Then we're going from here down to 32 by 32 by 16 depth. So this is like 16 deep now. And then from here, maybe we go straight from here to linear layer. So here we should be like this is 32 by 32 by 16, right? And how many outputs do we want here? We want per pixel, is this thing part of the mask, right? Is at each pixel in this low resolution, what do we look like? Yes. Okay. And so this is just going to be output is 32 times 32. We're dropping 16. And then here, maybe sigmoid makes more sense. Because we're trying here at the end to be like between 0 and 1. I think that makes sense. Okay. And so now we need it so that we have a 32 by 32 by 16 thing that we can like compare our answer to calculate our loss, right? So I think all we have to do here is we take like the bars masks and we do a max pool on this, right? So anything that is 1 will stay 1 at low resolution. And I think we just go like, we're trying to get to like 32 by 32, right? So we're going from like 256 to 32 is stride what? 32 times 8? 256 is 2 to the 8. This is 2 to the 5? 4. 2 to the 4. So we do stride 32 times 4? No, that can't be right. 256 over... Hold on. Am I stupid? Yeah, it has to be a power of 2. I see. So 256 over 2, 4, 8? Yeah. 8. Oh, right. So 2 to the 5 is 32. 2 to the 8 is 256. 8 minus 5 is 3. So it's 2 to the 3 is the thing we're dividing by. Thank you. So we do math executor max pool here on our masks. And we just like max pool these with stride 8. So this is like expected output. And we should be able to just fucking feed that shit in here. I think. And then I think everything just works because per step in the trainer here, he just does like mean squared error on the correct version versus what we got. So maybe we need to do like a reshape at the end here, I think, to like get it to be the right shape. So this guy is like, we're expecting a 32 by 32 by num images, right? Here. I think. And like maybe that works. 201. Oopsies, no, 601, my bad. So here he's mad that indims is the wrong size. Right, so we need to do masks reshaped. I think we just need to make this single channel. Yeah, for this to work. Yeah. Because this guy's expecting 4 dimensions. So we want this to be like math, executor, reshape. This is like barcode size, single channel, train num images, like this. Okay. Which means that it's easiest for us to reshape at the end to match that in our layers as well. So just huck a 1 on here. Something like that. What is it gonna like? We do need to give him the input. So true. Okay, maybe. What's he pissed about? Unreachable assertion at NNZig 124. We need to reshape before going into the linear layers as well. So true. So true. Still doesn't work. So he's mad now at the reshape. I mean, it must be this one, right? So 32 by 32 by 16 train images. What the fuck is the problem then? So we did 128 over 2. Sorry, 256 over 2. 128. 128 over 4. 32. Okay. Then we do some convolutions. We should have 30 by 30 by 16, no? Can we, at the very least, write down? How do you get like this? Just like, you know how we're like not using a neural network framework? Just like if you did that for everything for like a long time. Like just like 10 years plus of just like always digging. You'll eventually, like just the more things you do, the more things you'll have in the belt. And eventually you'll like, you know, have stuff to like that you can pull from. It's just like time in, really, I think. So this is just like the wrong number of dimensions, which is surprising. Or the wrong, they don't match up. Can we print out what happened here? Invalid dims. Invalid reshape, we can say in to out. And we can say here that we have like val dims and new dims. Like this. Let's see what he's fucking yelling about. So we're trying to go from 8 by 8. Am I stupid? Oh, yeah, because this is 64. Well, yeah. Barcode size here is still small. This we want it to update to 256. Okay. Hype. That is doing something. It's very slow, but it's doing something. Okay, let's copy the image generator parameters that we had before. So over here, we like updated our parameters to like be kind of more put barcodes in shit. And can we then put these in main somewhere in our training loop? So here, just copy paste this for now. Okay. Is lagging also your stream? Only when training, probably, right? Okay. So it's fucking Nan. Get me out of here. And like sound is okay, right? I don't really mind if the video lags a little bit, but if like the sound gets crackly, then that's like a real fucking problem. Okay, so we have default LR somewhere. Let's just drop this like a lot. Sound is good. Okay, then hell yeah. Hell yeah. Okay, what we got here? Okay, so we do have loss here. It is decreasing. And what I would love to see is, can we start looking at the final output here? The question here is, does this seem like it matches this? The answer is an obvious no. Right here, it looks like what it knows right now is to just predict the center. But maybe over time, it will start to learn something more reasonable. Right, so we're looking for this number here, this like 13,000. We're hoping for this guy to eventually drop. And I guess it just depends on if that's gonna happen or not. It looks like maybe no. What we should also do is we should be able to visualize like our correct answers here. Yeah, it would be interesting to see. Well, maybe it is shrinking. Maybe. Let's look at what the outputs are looking like. We could also try to do like ReLU activation at the end or something. Like maybe our final activation isn't that great. But or maybe we could increase the learning rate a little bit here. Let's go up to like 0.02, see if that does something. We NAND very quickly by doing that. So we have to be very careful with that, I guess. But maybe we can go a little higher than 0.001. Maybe we can go up to like 0.009. Maybe let's see if that gives us something. No, it does look like this is like freaking out like immediately. So, interesting. I'd be interested to try... What if we did less here? I don't have a good answer. I don't have a good answer here. We would have to inspect... I guess we should inspect where like the gradients are going and stuff. Maybe? So let's look at our gradients. Just pause for a second. And okay, so it does look like we are getting gradients that are making it back to our kernels, right? We are seeing these gradients make it back. What about like our weights here? Are these like changing at all? So let's just like pick one at random and hit play a couple times. So I'm hoping to see this 10.1055. This is barely moving, right? We're seeing this is like not moving at all. What about like this one? Yeah, barely fucking moving. What about this one? This one is moving like visibly, but it's still not that good. You lag as fuck. Yeah, good point. Good point. It's because like my GPU is doing the video encoding and my GPU is also fucking busy. So I would hope here. So the problem here is that like if we try to increase the learning rate too much, we immediately start freaking the fuck out. But the learning rate is too low for these guys to learn anything at the same time, right? Which is pretty interesting. I don't really know what to do with that. I don't know what to do with that. Where is the nan even coming from? That's a great question. Probably like gradients that are large, resulting in kernels that have nans in them, I would assume. Like divide, or like a divide by 0 or something. But yeah, let's try to see. Or like an infinity somewhere. Okay, let's see. Okay, pause. Okay, let's look at like our weights. Yeah, so here we're seeing weights in our like initial kernel. These are all just like nans everywhere. Which is kind of interesting. Shit. If we run out of memory when we're trying to copy this stuff to CPU, it just never recovers. That's not good. We should fix that. But for now, we can just up the size of our CPU side buffer. Time for learning rate schedule, maybe? Yeah, or like a better optimizer too would probably help us a lot. But can we do like 50 or something? Like where is this out of memory coming from? There we go. Yeah, a learning rate scheduler also maybe what, so you like start low and then like kind of turn it up a little bit over time and then turn it back down or something? But even then, it's like I can't really go very high before it's like a fucking problem. I guess like in normal learning rate schedules, they like they do something more intelligent, right? They how do I say this? Uh they like check if you nan and then decrease the learning rate or something if it does or something, right? What if we turned off these background images? Just to see if like the concept is working, right? Maybe we've made the problem too difficult for it to like immediately converge like it was before. So can we just go like you know, our params background color or something? So this should make the problem way fucking easier. Way easier, right? Because now he's just comparing like gray. So if he can't really figure this out, then we've got like a fucking problem. Oh fuck, I made the learning rate way too high. Way too high. I fucked up. I fucked up. Yeah, fuck. Fuck, 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 fuck. Yeah, so maybe wait, hold on. Hear me out, hear me out. We just make it easier. We make it easier. So we go fucking 1 to 4, 4 to 4, 4 to 4. And let's see if like these 16s become 4s. And let's just kind of see if this kind of, since it will train faster. Oh fuck. Seg fault? Why are we ooming? That was weird. So we should be able to get more iterations here, which, oh yeah, when I pause, it's freaking out. That's new. We're just, oh, but are we ooming then segfaulting or what? What the fuck is going on here? It takes a long time to initialize under GDB, but hopefully. So it's like when I press pause, he instant crashes. Like, what are you trying to do here? He's trying to update some text. Uh, yeah, okay. So we have new text here is uninitialized memory. So this is like coming from where? This is our like label for uh interesting. Interesting. Are we right limit and the button callback pushes over the edge or something? I would think no, but I guess it is worth checking. So can we like throw 100 here? Just give us a little more room. Yeah, it could be, because when I pause now, it's doing a lot better. No more crashy. Yeah, so it could be. So it could be that we and then the is causing a seg fault afterwards. That would make more sense. Okay, so the question is will this eventually learn something sane? Uh, okay. So like these guys, are these guys changing? I do see movement in these kernel values, which is good. And this value is going down over time. We are seeing it kind of go towards 10 now. We see a 9 in there. So that's like not guaranteed to be shit. Like maybe it is learning something here. Can we look again at like the final output? I mean, that's looking like it's starting to look like something sane. Right? If we can we flip-flop between like training sample here and oh yeah, that's like a maybe. Right? Yeah, I think that is starting to look like it's converging on the right answer, right? Let's let it run for a little more, just to see. What we should do is we should visualize it on top somehow. But yeah, look at this, look at this. He's down to like 7,000 now. We're going down towards 6,000 almost. So it does look like this, like the training data here is like correct, right? We're starting to see this starting to like resemble this. And what's actually kind of fun now is also, oh no, we somewhere. Fuck. That sucks. Oh, I actually might be on the other thread as well, actually. Hold on. I think it's actually that it's trying to like calculate the loss and like loading loss for a bunch of stuff and it's like running out of room. I'm just gonna bump this up to 50 for now too, just so I don't have to worry about it. Just give him 5 gigs. No! You can't make me. But what's kind of fun is you can start seeing like if we can get this guy back to like kind of doing something a little bit sane. Let's like give him like maybe 20 more seconds. We're hoping I guess we can like watch the layer output as well. And we can start to see when this starts to look a little bit more confident in his answers, right? Ram doesn't go on trees. Yeah, exactly. Here we go. He's starting to look a little bit more confident. We'll give him a little time. But what we're going to be able to get to do, I hope, if we can get this to work right, is hello, pause. We should be able to look at like other layer outputs, right? So we can look at like how these like convolutions, like what do they find interesting, right? So you can see like it looked more cool with the originals, but right, you can start to see like stuff like this happening where he's like kind of like looking for the borders of the barcode here. These guys have learned nothing of value yet. There's nothing of value here. Who fucking knows, man? But anyways, it's cool. It's cool. Okay. So I'm probably going to do some experiments offline with like seeing if I can get it to learn a little better. Oh yeah, look at that. Look, you can see it like totally starting to like isolate now. He's jumping around in a way that like might make sense. Look at that right here. He's most confident here that he matches. And you can also kind of see like the whole network is kind of like it's more likely to be in the middle, which is kind of funny. He's like always predicting a little bit because like maybe. But I think that I'm gonna just need to give it more time and maybe more parameters or less parameters or whatever to start learning like with a proper background. So I'll probably do some experimenting offline there to see what that looks like in order to get like something that works correctly. And then I'll also have a better feel for what we need to make fixes for on the optimizer. I think likely we'll come back tomorrow and try to like make it so that training is more stable. Oh yeah, look at that. He's starting to get like really, look at that. Look at that. Look at that. We can rip through a few images too. This one, boom. This one, boom. So obviously not great, not perfect, but yeah, we'll see. Cool. I'm really happy with that progress for today. I'll pause it so that I'm not laggy for the outro. But yeah, very happy with that progress. Very happy. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 Pacific time. It's 4:30 Pacific time if you're watching right now live. You know, so anywhere between like 4 hours ago and half an hour ago is when you should expect to see us. Some stuff goes on the YouTube, some stuff does not, right? So like kind of like I try to do like new feature development hits the YouTube, and things that like are harder to get clicks on. Like today we were doing a bunch of refactoring and getting like some of like the original CNN stuff merged. It's like harder to get clicks on those, especially if you're posting like 4-hour videos, right? So the rest of the stuff goes up behind the paywall on Patreon, YouTube member, and on Twitch VODs. If you subscribe/pay in the appropriate spot, you get access to the VODs and the knowledge that you're helping the stream stay alive, right? Because at some point I will probably run out of money and I will have to get a job and I will probably stop streaming, but every dollar I make extends that, you know, pushes that day a little bit farther out. So thank you for contributing if you have. Think that's all we got to plug. YouTube, peace out, and Twitch, let's find someone to raid.